time. So we set the stage on Monday for forensics and focusing on a problem domain, albeit using these same fundamentals of recovering information or covering your tracks when trying to get rid of information. To begin to discuss how information is actually stored on something like a hard drive, we actually need to be able to represent the data on a hard drive in actual programmatic terms. So just as a flashback, you might recall from week 0 what is actually inside of a hard drive. We'll just watch the first part of this for a few seconds. Recall that this was the story.
Is where your PC stores most of its permanent data. To do that, the data travels from RAM along with software signals that tell the hard drive how to store that data. The hard drive circuits translate those signals into voltage fluctuations. These in turn control the hard drive's moving parts, some of the few moving parts left in the modern computer. Some of the signals control a motor which spins metal-coated platters. Your data is actually stored on these platters. Other signals move the read-write heads to read or write data on the platters. This machinery is so precise that a human hair couldn't even pass between the heads and spinning platters. Yet it all works at terrific speeds.
So the film, recall, goes on to just discuss, this is going to be a little messing with your mind. If we could focus the camera on the board here for a moment. So you'll recall that the video went on perhaps to show those little blue and red magnetic particles and to reduce the problem of storing information on a hard drive to the orientation of magnetic particles, either north-south or south-north, thereby representing 1 or 0 respectively. Some system like that. Well, what's really going on in a computer's hard drive is obviously got to be higher level than that. There's got to be some notion of file names, some notion of file sizes, some notion of folders in which things are. So hard drives are not just zeros and ones. Rather, they actually have some metadata stored on them. And metadata means data, but it's useful for other data you really care about. So let me just draw, for instance, one of those platters. So this is a metal disk that's inside of a typical hard drive. And it spins around generally at thousands of times per minute. And all along here are zeros and ones in some orientation. Now, what's really going on there is that clusters of these zeros and ones represent more interesting things. They represent your actual files, like your MP3s and your movies, but also things like the file name and where things are. So it turns out, even though this might represent some movie you've downloaded from iTunes, there's a special part of the hard drive reserved for a table, sort of an Excel spreadsheet of sorts that has, to oversimplify, 2 columns. On the left is the name of the file, and on the right is the address of the file. So just like we can say that your RAM can be addressed from byte 0, 1, 2, 3, 4 on up, similarly can your hard drive, even though it's a circle, be described in the same way. This is byte 0. This is byte 1, 2, 3, 4, and some system along those lines. So how does your computer remember where data on your hard drive is? It uses this little cheat sheet. So when you create or save or download a file, there's this table in your operating system's memory that says, OK, you just downloaded movie.mov, some file name like that. And so the name gets written in the left column. In the right column gets written the address of, say, the first byte of that movie. Now, hard drives are actually pretty fancy, and so you can get what's called disk fragmentation. If you've got big files, they might not necessarily all end up here. You might get part of your movie here, or here, or here, or here. So if you've ever heard this term, defragment your hard drive, it's referring to the fact that your file might be spread out. So it's not sufficient just to remember the starting address of a file. Turns out there's usually a list of addresses. Part 1 is here, part 2 is here, and so forth. But now into the world of forensics. What happens when you actually drag a file to the recycle bin or to the trash can on Mac OS or Windows? So you probably figured this much out, right? Like, what happens when you just drag it to that special icon? Yeah, and actually not even there. In fact, we can rewind further. Nothing happens, right? If you drag a file, something sketchy or private that you want to delete, and you just put it in the recycle bin or the trash can, hopefully by now you figured out that your roommate can just double click your trash can or your recycle bin, right? So you actually have to do what? So empty the recycle bin or empty the trash can in some way. But what really happens? Well, despite years worth of our being trained by computer society that deleting means deleting, deleting does not mean deleting, right? Deleting means forgetting. So what really happens if you've got some financial data or some Dear John letter you didn't mean to send or you wanted to delete or something you don't want found, well, if you delete it by dragging it to the recycle bin and clicking empty recycle bin or empty trash, all that's happening in this picture is that. The operating system just forgets where it is. Now, anyone who's versed in the art of forensics, or anyone who has Google, can find a program that can then search your hard drive looking for what we'll call signatures of known files. It turns out a lot of files on the internet and in general have signatures, which just means they're identifiable by just a few bytes. For instance, if you detect this sequence of bytes on a hard disk, FFD8, FFE0, and these are just hexadecimal numbers. If you detect that on a hard drive, that means with very high probability you have just encountered the start of a JPEG. A JPEG is an image, a photograph. These are very commonly deleted from one's hard drive. And so you probably don't want it to be so easy for someone to just search your entire hard drive with an automated program and say, JPEG, 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 JPEG. But indeed, this is what forensic investigators do. I mean, this is what your roommate could be doing if he or she Googles for such tools. You can recover files from a hard drive with very high probability because literally the bits are still there. And just because your computer forgot about them doesn't mean there's not enough hints scattered around your hard drive to recover them. So that then begs the question, OK, how do I really delete these files from my hard drive? Right? So what do you do? Or what do you need to do technically, intuitively? Yeah?
After I delete all my dirty pictures, I could download a bunch of episodes of The Sopranos.
OK. You have a very concrete plan B here. So So after you delete your sketchy photos, you can download some very big Sopranos episodes online. And that's actually quite clever. That would have the side effect of overwriting your sketchy photos, because even though your computer's forgotten that these files are there, as soon as you start downloading a huge amount of content, big movie files like Sopranos episodes, with high probability, these zeros and ones, they're not going to get erased per se, but they're going to get reused. Those magnetic particles are now going to be part of some Sopranos episode. So now 50% of your sketchy behavior is now gone. Right? So if you've ever used something like Norton Utilities or any of these programs that undelete files, what they'll sometimes say, oh, we can delete this file with 95% certainty. Well, that probably means because 5% of the zeros and ones have been reused by a Sopranos episode or the like. Now, thankfully, there's even easier ways. This is sort of the like, oh my god, I really have to cover my tracks, download a lot of content. Thankfully, there do exist built-in ways, and different operating systems do this better. If you've never noticed, though you've had this probably if you own a Mac for some time, under your Finder menu, there's empty trash, but there's also secure empty trash. So secure empty trash will not only erase what's in this table, it will also overwrite the zeros and ones with it minimally all zeros. And there are Department of Defense standards that actually say, well, you can overwrite the bits with zeros and ones randomly, some 7 times, even more times than that. The research literature, there has been no published evidence that simply writing all zeros over your data on modern hard drives is insufficient. So you probably don't need to use Department of Defense standards to actually cover your tracks, whatever it is you're trying to delete. It generally suffices to overwrite zeros and ones. And this isn't a Mac versus PC thing, but Apple has been much, much better in recent years at making this easy. On Windows, to my knowledge, there's no such super simple option as that. In fact, in Mac OS 2, and it's maybe fine because we're preaching to the choir since most of you, a majority, have Macs, you can also encrypt your whole hard drive. The thing called File Vault means all of your data is actually encrypted. So if it's lost or stolen, no one can actually see what your files are. They just look completely random. And there's even, if you're super paranoid, something called secure virtual memory. Long story short, when I mentioned earlier that your computer might slow down sometimes because you're loading lots of programs, well, typically, a modern operating system will not say, like it used to, you have too many programs running. I will not launch Safari again, or I will not launch Internet Explorer. Instead, what it will do is create the illusion that you don't have maximally 2 gigs of RAM. The computer will pretend that you have 3 gigabytes of RAM. And to create that illusion, it will take 1 gigabyte's worth of programs and files you have open, temporarily copy them from RAM to your hard drive somewhere, and then voila, you have a gigabyte that you can use for new programs. But which is slower, RAM or hard drives? Well, the short answer is a hard drive is generally something mechanical, though this is becoming less and less true. Anything mechanical is going to be slower than anything electronic, and RAM is purely electronic. So one of the reasons your computer slows down when you're doing lots of things is because you're using virtual memory, hard disk space, as though it were RAM. But here's the security worry. Even if you're good about deleting your browser's cache and you even empty securely your recycle bin or trash can, it doesn't matter, because those sketchy photos you had open in your program might have been temporarily put into virtual memory, which means put into some special part of the hard disk that you don't have easy access to delete. So unless you enable something, and I think if I go in a Mac, System Preferences, Security, General, yeah. So it's grayed out right now, but this option here, Use Secure Virtual Memory, is checked here by default. That means that even your virtual memory is encrypted. So we'll come back to this in problem set 5, but realize that there's a lot of ways to both cover or accidentally leave uncovered your tracks.